All right, class. So today, we are going to start the next unit, which is on factoring and quadratic functions. This is a major unit, and if I don't start it now, I'm afraid might not finish it. So we have to get started. Okay, I want to get started, and then at the end of class, if you have questions about your test or something like that, then I will be able to assist you with that as well. Okay, this is going to be page 5. We're going to put Q4 at the top, quarter 4, and this is page 5. Today's date is 4/15/21. The title of this page is Intro to Quadratic Functions. The title of this page is Intro to Quadratic Functions. Okay, we've already talked about linear functions, which form straight lines. We talked about exponential functions, which have curved lines. They grow by either an exponent or, well, a common ratio or a percent. And now we're getting ready to talk about quadratic functions, okay? Now we're going to talk about quadratic functions. All right. The thing to remember, I'm going to put this in a bubble, but I'm going to write something that we need to make sure that we remember about all functions, because sometimes we forget as we move from unit to unit. Remember that function is where x values do not repeat. Okay? It's where your x values do not repeat. Super important to remember. We learned that in our very first unit, and that goes throughout the units with linear functions and exponential functions and quadratic functions. It's still the same. A function, okay, is where your x values do not repeat, and they pass the vertical line. They pass the vertical line test. Okay. All right. So now let's focus on let's define what a quadratic function is. Okay. So we're going to do a definition for a quadratic function. Quadratic function is an equation of a function that graphs an upward or downward U-shaped line. Upward or downward U-shaped line. And another word for a U-shaped line is a parabola. Another word for a U-shaped line is a parabola. So quadratic functions graph U-shaped lines or parabolas. Either the U is going upward, where it looks like a U, or it's going downward, where it's an upside down U. Some people draw their ends that way. All right. Examples of what that looks like. Now we're getting into examples of what parabolas look like. We're going to do 2. So we're going to draw 2 coordinate planes, okay? Got an x-axis and a y-axis. Just like we did with linear functions and exponential functions. We drew what they look like, okay? Some quadratic functions have upward parabolas, or a U-shaped line. So this parabola is an upward U. So you'll know the difference. And then other quadratic functions look like this, where it's a downward U. So this parabola is a downward U. Okay. Okay. I'll pause for the cause. These are quadratic functions. They are equations that graph lines that either have an upward U or upward parabola or a downward U or a downward parabola. Okay. U-shaped lines are called parabolas. U-shaped lines are called parabolas. Okay. No sideways U's, only an upward U or downward U. No sideways U's. Questions, comments, or concerns? Okay. And over out here to the side, just in case you forget, this is a little mental note. Parabolas are U-shaped lines. Put that in a little bubble out here. All right. So now we're going to focus on the equation part. Okay. Just as we did with linear and exponential functions. There's a standard form for linear functions. There's a standard form which was ax plus by equals c. There's a standard form for exponential functions, which remember is that y is equal to a times b to the x power. And now we're going to do the standard form for quadratic functions, okay? So the standard form and this is how you will see most quadratic functions. This is what you see most of them looking like, okay? Standard form for quadratic functions. Or equations. Where you have y, let's do y is equal to a x to the second power plus b x plus c, where a, b, and c are numbers. A, b, and c are numbers. Equations that have the x squared terms are going to graph U-shape. So even if you don't have these two terms, this is still a quadratic function because it has an x squared term. But without the x squared term, this would not be a quadratic function anymore. So really what makes quadratic functions is the x squared term. Without it, it would not be a quadratic function. You cannot have a quadratic function if you don't have the x squared term. Any questions? Okay. So let's write what these mean. Okay? All right. So far, you have your y. It's right here. Your y, I'm going to put it up here so I can have some space. Your y is your output, same as all the other functions. Your y is your output. And I'll actually do a table instead of just saying what it equals to. So, because we've done this so many times before, you have tables on other pages. So synonyms for x and synonyms for y, it's the same for linear, exponential, and now quadratic. Your x values are called your domain, your input, your independent variable. Okay. Those are synonyms for your x. That's your input. Most time it's time, right? Months, days, years. Most of the time it's the same. It's consistent with linear, exponential, and quadratic. Okay? It's still going to be graphed along your x-axis. Your y. Other words that mean y. It's range, your range values, your output, your dependent variable. It's dependent for linear, exponential, and now quadratic, because the answer, your output, is dependent on whatever x is. In order to find y, you have to know what x is. You can't find y without knowing what x is. So that's why y is always our dependent variable for both, for all three, linear, exponential, and quadratic. And the last for y is the f of x, okay? F of x is the same as y for linear, exponential, quadratic, for whatever function you learn about. F of x is the same as saying y. Any questions? Okay. All right, so now let's break down what the A, the B, and the C means in a quadratic equation, what those numbers mean, because A, B, and C are all numbers. All right, let's talk about the number A and the meaning of that. A is the number that is attached to x squared. Obviously, we can see that. If that number is positive, the parabola is going to go upward. It's going to do an upward parabola. If this number right here is negative, then your parabola is going to be graphed down. Okay, so that's super important. If the number is positive, the parabola is upward. If the number is negative, the parabola is downward. If the number is negative, the parabola is downward. The parabola is downward. Okay? So that's what A is. Right? That's what A is. Okay? Now we're going to focus on what B is, okay? We're going to focus on what B is now. And I'll pause for the calls to give you a chance to write. Are there any questions so far? Now we're going to talk about what the B is in the quadratic function. So let's talk about B now. Your B in the quadratic function is going to shift your quadratic function from either left to right, okay? It's going to shift the parabola from left to right. That's what this middle number will do. Either shift it to the left or to the right. That's what that number does. It shifts it to the left or to the right. Okay. One more thing you'll notice about your A that I didn't write it here, that's going to make it go either wider or narrow. It also makes it go wider or narrow. But when you start playing with numbers, you'll see what it'll do. Okay. All right, let's look at C. And what does that number for quadratic function? What part of that makes the parabola? The C is going to shift the parabola either up or down. So C shifts the parabola up or down. So C shifts the parabola up or down. Okay? I'm gonna pause for the calls. All right. Okay, so now we just want to look at what quadratic equation or functions look like. So that's what we're going to do. Just look at some equations. So we got quadratic equations or functions. Okay. Look like, and this is what they look like. You might see quadratic functions or equations that look like this, where you have y is equal to 2x to the second power. This is what makes it a quadratic function because of this x squared. Without it, it wouldn't even be a quadratic function, okay? And then you have a b term, and then you have a c term. So this, you might have all three terms. You might just have two of those terms. And it might look just like this. You might have the A and you might have the C. Notice I say this is C. Why is this C? Because it doesn't have a variable attached to it. Okay? The A term has the x squared attached to it. The B term just has x attached to it. And the C term doesn't have a variable at all attached to it. It's a constant. It doesn't have a variable at all attached. Okay? So you might have this. This is still a quadratic function, even though it doesn't have the b term. Why? Because it has the x squared term. You have to have the x squared term in order for it to be a quadratic function. And then lastly, you might see a quadratic function that just has the x squared term only. Okay? It just has the x squared term only. And it is still a quadratic function. Why? Because it has the x squared term. Any questions about that? So I'm going to put an asterisk here. And don't hesitate to ask questions, okay? The asterisk here is going to say quadratic functions must have the x squared term. Without x squared, it is not, that's super important, a quadratic function. Or equation. Any questions? All right, the last thing that we're going to write about quadratic functions today, and then I'm going to address your concerns about your test, okay, is ways to graph. So to graph quadratic functions or equations, there are two ways to do that, just two. two ways to graph a quadratic function. The first way is to use the calculator. All of them, you can use the calculator, right? Okay. And in order to do that, the only thing you press is y equals, and then you type in the equation, and then you're going to press graph. Simple. Okay. That's all you do. You go to y equals, it's right here on the screen. You type in the equation. I'm going to type in x squared. This is a quadratic function, and you press graph. That's how you graph an equation. All right? Okay. Any questions about that? The second way to graph a quadratic function is to create a function table. And you can do this for any and every function, okay? Create a function table. And you create them the same way you create any other function table. If the equation is y is equal to x squared plus 1, I'm going to use a simple. This is a quadratic equation. This is all you do here. Create the function table just like this. You put your x values here, which remember your x is your input, your domain, okay, your independent. Then you're going to put the equation here or the rule. Sometimes they say rule or equation. It's the same thing, okay? You put y is equal to x squared plus 1. Somebody's coming in. Okay? And then you have your y, which is your output. Okay? So all you're doing, graphing this on paper. Please don't use x values that are beyond what you want to graph. Okay? Don't do that. I'm going to start with 0 because, that's here. X is 0. I'm going to plug in 0 for x and see what I get. I get y is equal to 0 squared plus 1. Well, 0 squared is 0. 0 plus 1 is going to be 1. So my first ordered pair is 0, comma 1. So I'm going to graph 0 and comma 1. I'm going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. All right. So now I'm going to graph 0 and 1. So 0's here on the x and go up 1. Okay. Now I'm going to choose another x value. I'm just going to choose 1, okay? And you can choose whatever x value you want. Just don't make it too big because you need to be able to graph it on paper. So we got y is equal to, plug in 1 for x this time. So that's 1 squared plus 1. 1 squared, 1 times 1 is 1. Then we're going to add 1 using order of operations, and that gives us 2. So we're going to graph 1, and we're going to go up to 2. 1, 2. Okay? Now I'm going to do 2. All right, looks like a straight line, so you have to do several points until you can see the U. Okay, you got to do several points until you can see the U. You can't just do 2 or 3 points because that's not going to give you a U shape. You know it's going to be a U shape because it's an x squared. So you got to keep graphing points until you can get that U shape. So now we got y is equal to, we're going to plug in 2 to the second power plus 1. So 2 to the second power, that's 4 plus 1, which is going to be 5. So I'll go over 1, 2, and I'm going to go up this time to 5. 1, 2, 3, 4, and 5. Okay? So now I see a little curve going on here. So I kind of can figure that I need to go back this way. Okay. So I'm going to go to -1. All right. I need to go to -1 to see maybe if it goes down or maybe it's going to curve and go up. I don't know. Let's see. So let's plug in -1. So we got -1. I'm putting in parentheses because negative goes with the 1. So I got -1 squared plus 1. So -1 times a -1 is a +1. And then we got +1. So that's going to give me 2. Okay. Because a negative times a negative is still a positive. So that's going to give me 2. So I'm going to go over to the -1 and go up 1, 2. Well, what do you know? I get a curve. Okay, it's curving back up. So now let's do -2. Okay, so I'm going to plug in -2 now. So here, the negative goes with the 2, so that's why I'm putting in parentheses, because I need to multiply -2 times -2. Okay, so -2 times -2 is going to give me a +4. So I have 4 plus 1, which is 5. So I'm going to go over to -2, 1, 2 on the x-axis, -2, and I'm going to go up 5. That's 1, 2, 3, 4, and 5. So now I get what you call a U shape. And I put arrows on the end because just because I stopped graphing points, this parabola is going to go on forever. Okay? This parabola is going to go on forever. Any questions about that? All right, this is where I'm going to stop my video unless we have any questions that I need to add. Okay, I'm going to go ahead and stop it here. Is there anybody that's still copying? Okay. All right, you can go back and watch this video if you need to. I'm going to upload this on our page, or I'm going to send it to you in Remind, okay?